Hi, welcome to CSE114 Introduction to Object-Oriented Programming, and this is Basic Programming Concepts 2. So I started Basic Programming's concept part 1 in the previous video lecture, and where we looked at the different variable types, and since we will be writing program and mostly our programs will be dealing with some data types, so Java provides us different kinds of data types, so we have looked at that. So in numerical, if we have to deal with numerical data, then we can, for numerical data, we can have either integral values, which means the whole numbers, or we may deal with some decimal numbers where we'll have decimal point and we'll have some fractions after decimal point. So we have seen that for integers we have four primitive types, like byte, short, int, long, and then we looked at the double and float, and double and float are the data types for representing decimal values. Then we also looked at character, which is CHAR. We represent character with CHAR. And then we also looked at Boolean data type, and we looked at string, and I gave you some idea about the primitive data types and the reference data types. So then we also looked at the casting a little bit. So this is where I stopped. So these few slides that you will see would be the repetition of the slides from the previous lecture, just for the sake of completion. So let's resume from where I left, and we were looking at the conversions between different kind of numerical values. So for some numerical values there is a default conversion that Java provides, but for other kinds of conversion, if we want to do in numerical values, we will have to explicitly specify that to Java that we want this conversion to take place, and then only Java will do that. So when we specify Java to do a specific kind of conversion, then we use casting. All right, so let's look at that concept one more time. So we have some examples here. So let's see. This statement which says integer x is equal to 5 means that x is a variable, its type is integer, and you are initializing that to 5. So you're doing two things in this statement. First, you're declaring the variable x, and its type you're saying should be an integer. That means Java will fix, or allocate 4 bytes for x. Why? Because integer has 4 bytes in Java. So for x we have 4 bytes allocated, and in those 4 bytes, which will be denoted by x, you are storing a value of 5. Okay, so that's what we mean. X being declared as integer with this statement int x, and x is also assigned a value 5. So we are doing declaration as well as assignment in this statement. Then the next statement that you have is the one where you're declaring y as long, and long is an integer data type which has double the capacity of an integer. So a long will, if you declare a variable as long, then the Java will store 4 bytes for that, 8 bytes for that variable. So y has double the storage capacity as compared to x, because x is an integer whereas y is long. So what happened in this case, you declared y as long, and you also initialize the value of y as x. Okay, so what has happened in this case, the value that you're getting, which is x, is in fact a variable. In x you have a variable which is of type integer, and that integer value you are assigning to a long variable. Okay, so this is fine. So when you have okay, so this relates to the concept right here, which says that you can assign little type to okay, so the point is that the long has 8 bytes. Sorry about that. So since the long is for integer and similarly int is for integer and long is 8 bytes, whereas int is 4 bytes. So from lower size to the higher size is allowed. Okay, so that kind of assignment you can do. So for the to check whether this assignment is proper or not, we should look at this ordering. And in this ordering, if you're making an assignment from the left hand side to the right hand side variable, then you are fine. Our x that you have here is of type integer, which is on the left hand side of y. Y is of type long, so this is perfectly fine. You can do that assignment. Okay, so from a variable of a lower storage size, if you're doing an assignment to a variable of higher storage size, you are fine. So this is allowed. Okay, now let's see what are we doing here. So in this case, you declare a variable z and its type is double. That means z will be capable of storing decimal values. Alright, that's fine. So z is being declared as double. But what you're doing here, in the double variable, you're assigning a long variable, right? So if you remember y, if you look back at this statement, you'll find that the type of variable y is long. Alright, now you should check, is it allowed? Can I assign a value of a variable which is of type long to a variable which is of type double? So for that you should look at this order. Okay, so long is here on the left hand side of double. Okay, so z is right here. So since long is on the left hand side of your double and you follow this order, which is less than kind of thing, so which means that in this ordering y is less than y, which means long is less than double, so this is allowed. You can do this assignment. Okay, so this rule you should remember in order to make out that whether this assignment is being allowed or not. Okay, so for the same reason, the reason that the double is the rightmost, whereas the long is somewhere on the left of double, so this assignment is perfectly fine. Okay, all right, so now let's see what will happen here. So these sets of statements were perfectly fine. Now if you look at this case where a has been declared as double and is being given a decimal value which is 6.5, so you have a decimal point and you have something after the decimal point on the right hand side. So this is 6.5 for which you are assigning to a variable a and its type is double. Perfect, no problem in this statement. Now what you did in the second statement, you declared a variable b. Let's pay attention to the left hand side. You are saying b is of type long. That means an integer of size 8 bytes, right? So in 8 bytes you will be storing 8 bytes are being assigned for the variable b, and you're declaring that it has to be long. Alright, so long means integer, and for integers you do not have support of representing a decimal. So the decimal point, if you have to store, what I mean to say is, if you want to store a value which has a decimal point, then that value cannot be stored in an integer variable type. Okay, so that's another thing that you should keep in mind. So this assignment of a, which is a double variable, to a long integer is disallowed. You cannot, because in an integer or long integer type you don't have the support of representing a decimal point. Alright, so you can understand this thing by this logic, or you can look at this ordering also. So what is this ordering saying? This ordering is saying that your a is right here. Alright, A is the one that you're using for assignment, which is right here, but B is here. So you're making an assignment of A to a variable of type which is on the left hand side of the value that A has. So A has double value and you want to assign that to a variable of type long. So what we are doing, we are going in the other direction, we are going to the left, and this left kind of movement is disallowed. Alright, so this assignment will not work. As long as you are moving in the right hand direction, that is fine. Okay, so in all these cases that you saw, we were moving on the right hand side. Right hand side means the lower side, the lower data type was assigned to the right to the variable of the right hand type. That means a bigger variable type, bigger data type, or the larger size data type. That's how you can interpret it. Now what is happening here? Fine, this should not happen. How about this case? Integer c is equal to b, right? So what I can do, let me add this thing here. I know that this was not allowed, and if I say that long of b is equal to 25, all right, so this is fine. Why? Because the type of b here is long, okay, and you have assigned a value of 25. Now if you want to assign if you want to do this thing, which is integer type c is equal to b, then this is a problem here. Why? Because when you assign 25 to a variable of type long, then this was represented in 8 bytes. Alright, and when you want that to be implicitly assigned to c, which is of integer type, that means it has only 4 bytes. So a value which was represented in 8 byte, you want to represent that in 4 bytes. So that is a problem. Okay, so Java will not do that by default. You will have to enforce that. Okay, so this is also disallowed for the same reason, because where is c? C is right here, and where is b? B is right here. So you're moving in the left hand direction. Okay, you are assigning a value of type right hand side to the left hand side, which is not allowed. Okay, so I hope these things are making sense to you. If not, please let us know, because this is very important in Java programming. Alright, so if you really want to enforce this kind of conversion of a value from the larger type to a smaller type in numerical expressions, then there's something called as casting. So you should make use of casting. Alright, so how do we cast? Let's use that. Use this example. Suppose that you have my real and its type is double. You have given some value to my real, which is 10.0, and what you might think that, well, in my real, if you look at, I have 10.0. That means after decimal I have zeros. So anyway, Java should consider 10 and should discard decimal point and 0 afterwards. Okay, if you assign that my real to an integer value in this way. Okay, so your intuition might be that the variable my real, which I am declaring as double, has 10.0, and after decimal we have a 0. So if I make this assignment like my real into an int variable like bad int, then everything should be fine, and in the bad int I should get the value as 10, right? Unfortunately, this will not work. Why? For the reason that you cannot assign a decimal value to an integer, because in double you do have the support to represent a decimal, but in case of integer you don't have a support to represent a decimal. So this is a bad idea, and Java will not do that by default. But if you want to enforce it on Java, right, then it will do it. So how can you enforce? You'll have to use casting. Alright, so how do we cast? Well, for that variable which you have as my real, you will have to tell the Java that, you know what, I want this double value to be casted or to be converted to an int. Alright, so this is the rule. If you want the value to be changed from another type to the type that you want, then you will have to put that type in parentheses. Alright, I want this my real casted into integer. So before this variable name, which is my real, I'll put an integer. So the impact of that will be that out of this decimal number, which is 10.0, it will truncate 10.0 and will take the integer part out, and that will be assigned to good integer, and this is fine. And the result of this will be that the good int, a variable that you have, will get the value 10, integer 10. Okay, and this was only possible after using casting. If you don't use casting, then you will get a compiler error. Okay, so let's look at let's look at another very important operator in programming. That's so in Java, this equal thing. All right, so please do not confuse this operator in Java, right? So in Java, when you use this operator, which in mathematics we call as equality operator, so in maths, right, so in maths you call it as equals operator. You check for equality using this operator. But in Java, this operator is called assignment operator. Okay, so if you are new to programming, then probably this will be one of the problems you'll face. This results in a lot of errors, a lot of bugs in the program, because we often confuse this this assignment operator in Java with the equal operator in maths. This is the same thing, but we can use it in maths for checking equality, but not in Java. If you use this thing in Java, then that means it is for assignment. Alright, so what is this assignment? Well, let's look at this example. If you had a variable like this, okay, let me add one more statement right here. I will say integer x. Alright, so what you did in your program, this is a comma, okay, I hope you're getting it. This is a comma, this is a semicolon, semicolon you call it, right? So integer x semicolon, that means you're declaring x as an integer, and after that you can say x is equal to 5. So here this equality that you have, this equal sign that you have, is in fact an assignment operator, which says that the value that you have on the right hand side, which is 5, is being assigned to x. Alright, so this thing that you have, this operator, is called an assignment operator. Okay, this is called assignment operator because it will assign whatever you have on the right hand side to the variable that you have on the left hand side. Okay, yeah. So the same operator will be used for assignment for different kinds of data types. So let's look at another example. Here our variable is of different kind. So foo is of type character, char, right? And for a foo you are assigning a character g. Okay, and of characters, character literals are represented in single quotation. So this is an example of character literal. I can have some more examples, small z, but only this will be a character literal only when you put that in single quotation. Similarly, this o, small o in single quotation, these are all character literals. Similarly, you can represent even numbers like 0, 1. When you put 1 in the single quotation, then this one would be treated as a character. But if you have just one like this, then this is an integer. Alright, so these constants that you see in programs, right? These values, we should say, we should not say constant, because constant is something different in programming. Now these values which you are assigning to the variables like 5, G, and these characters right here, they are all called literals. Literals means the actual values. Alright, so these things will reappear in your programming, so you better um, remember these words. Literals means the actual values which you might be assigning to the variables. So 5 is an integer literal, right? It's an int literal, and then all these things that you're looking at, these are all character literal. You can have values like 2.75. This is double literal, and similarly you can have string literal as well, like Sam, the name of a person. This is string literal. Alright, great. So let's move on. Now, what are constants? So when you are writing a program, you might encounter some scenario where you want some values to remain constant. Okay, you need to enforce the fact that these values should not change in your program, and if there's any attempt which is made to change that value or that variable, then I should not call that variable, because variable means something that can change, right? So constants are those values which you have in your program and you don't want those values to change. So if you're writing a program which involves pi, all right, so this pi from mathematics, 3.1415, so you have this value right here. So this pi is very useful for mathematical computation. As an example, if you have to find out the area of a circle, then you will compute that as pi r square. So you should have the value of pi in your program. Now, how should we declare pi to be a constant? I don't want this pi value to change by any accident in my program. So how do we declare that? We will use a keyword final just before the normal declaration. Okay, so if you had to declare pi with some value, declare and initialize pi with the value of the pi, then usually you'll do it this way. You'll say double pi and some value you will assign to pi. Now when you put a final on the left hand side of the normal declaration, then it will make pi as constant. Alright, so this final keyword is very important. Final double my constant is equal to 10. Alright, so what you have done here, double my constant, you can declare your own constant and its value is 10. So double my constant, if you keep that at 10, then you can change it. The program won't complain. Java will never complain if you just keep double my constant is equal to 10 and change the value of my constant. But if you put a final keyword before this this normal declaration, then it will never allow you to make any change to your constant, which you're calling as my constant. Okay, so please remember that this keyword final is very handy when you want to declare some constants in your program. Now there's a convention in Java which says that the constants that you have in your program, they should be capitalized. Look at the way pi has been declared and initialized, and similarly I am following the same convention and I am calling my constant as my constant, and all these are in capitalized letters. All right, let's move on. Okay, so now we will look at some basic arithmetic operations that we can perform in Java. So we have the support for addition, subtraction, multiplication and division for numeric values, and the symbol for that are simple. For addition you will use the plus sign, for subtraction you will use the normal minus sign, multiplication for that we use the star symbol, and for division we will use this forward slash. Okay, and then we have some normal order of operation, and I will share a slide with you where we will discuss the precedence. So precedence will determine like in what order these operators will work. Okay, so there is some precedence thing which I will discuss later, probably in our next video lecture. But in this lecture, let's at least look at these different arithmetic operators that we have available in Java. Okay, fine. Now there's one more operator which is very handy in programming. This is called the modulus operator. Okay, so what does this modulus operator do? So whenever you are doing some when you are dealing with the division, right, if you have some numbers like 12 and 7, so let's discuss this operation, which is 12 by 7, 12 divided by 7. So there's an interesting rule about the arithmetic operations which I'll discuss in the next few slides, but let me give you some hint about that right here. So when you do arithmetic operation in Java, then the first rule is that the operands involved, they should be of the same type. So right here the operation that we are doing is division. I want to do division and I want to divide 12 by 7. My numerator is 12, my denominator is 7. So the first rule for the arithmetic operation for Java says that your for division, at least let's discuss division, numerator and denominator, they should be of the same type. So here we are lucky, numerator is integer, the denominator is integer. So first rule is satisfied. Now the second rule says that when you perform this operation, then the result depends on the type of operands that you had. So my numerator was integer, my denominator was integer, so the result that you get would be an integer. Alright, so you'll say, what do you mean? So, well, that means if you do this division of 12 by 7, then probably you will get 1 point something, right, some fraction. But since your operands were integer, so the result will be also integer. Alright, so you will not get anything in the decimal. The result would be an integer only, and it will be truncated result. Okay, so the simple division of integer will result in an integer, nothing after that. Okay, no decimal, no fraction. Okay, fine. So this is an integer division which will only give you the quotient, right? You're getting only the quotient here, which is 1. Now if you are interested in finding out what is the denominator of this operation, right, here you got the quotient. If you're interested in remainder of this operation, then you should be using a modulo operator, which is written like 12 percentage, sorry, this is 7. Okay, when you do the division, okay, wait a second, I should erase. Alright, so let's replace that by 7. So what will happen? Now you'll get the remainder of this operation. So when you divide 12 by 17, 7 goes one time in 12, and you get the remainder as 5. Okay, so this modulus operator, okay, so this modulus operator will return the remainder of the operations like this. Alright, and this is very handy. You can you can solve a lot of interesting programming problems by using the modulus operator. Okay, so now to the rule that I was just kind of casually telling you. So for the rule of arithmetic, we should call it, is like this. There are two basic rules. Rule 1, both operands must be of the same type. Okay, and when the operands are of the same type, then the answer would be the same as their type. So we have seen that when we did the division of two integers, 12 divided by 7, we got the result as 1, which is integer. So both operands are integer, the result is integer. Now it is possible, right? It is possible that you may not have the operands in the same, it's of the same type. How about this, right? Let me put it this way. If you are doing 12.0 13.0, right? Now it will be interesting if I say 13.0 divided by 2. This is an interesting case because your numerator is double. It's a decimal value. You have decimal and a 0 after that. Whereas the denominator is an integer. So what would be the result, right? So these are different. Numerator is your double and your denominator is an integer. So how does Java solve this scenario? So when the operands are of different type, then they must be converted to the same type first before we do the operation. So what Java does, Java automatically expands the smaller type. Java automatically expands the smaller type to a larger type. So what does that mean? So here 13.0 is already is a higher type, which is double. 2 as an integer, so it will be converted to 2.0. Alright, and now this is double, the numerator is double, denominator is double. Now you can do the operation because numerator as well as the denominator are of the same data type. Now do the normal division, and the normal division should result in 6.5, I believe. Okay, please double check. I think it should be 6.5 because if you multiply, then you'll get 13. And the result is double. Alright, double division, numerator double, denominator double. Result is a double. Okay, so this order is again important for us to kind of remember. And you can reason as well, right? If you think about this ordering, it will make a lot of sense. Okay, now the type conversion, we have already seen that, so I'll skip this thing because I think it's a repetition. We've already done that. Okay, so probably I should explain this thing because in casting, right, so whenever you do a casting, so this value that you're looking at is double. Alright, it's a double value. This 3.14159 is a double value. You want its integer, you want to convert it into integer, and once it is converted to integer, you want to assign that to x. Alright, and you are doing it the right way. You're using casting. Alright, and the casting you're saying integer. That means you want this double value to be converted into integer. Now the most important thing that you need to keep in mind is that whenever you cast, then this casting results in this thing. Casting will result in truncation. Alright, it never results in rounding. Okay, so it will never round it. So as an example, say you have integer x, alright, and you're doing a casting, and you are casting 1.999999. Alright, so this is not rounding. If you do rounding, probably you should get 2, but it's not how the casting work. So the result of this will be truncation. That means all this thing gone. X will get the value 1. Alright, so that's the important thing. It does not round. It truncates. Right? This casting truncates. It does not result in rounding of the double in this scenario. Okay, so be careful about casting. Now these are some very interesting examples. So let's see what will happen. Okay, and yeah, these examples will help us really understand what I have just explained to you. So let's see. In the very first statement, average is being declared as a double type variable, and we are assigning a value which is 100.0 divided by 8.0. So let's see, we just learned the rule of arithmetic rule, right? So numerator is double, your denominator is double, no problem at all. So you will compute this value, which should come around 12.5, which is a double. So average gets the value 12.5. Okay, no surprise. It was a very happy situation. Okay, so that's the result. You got 12.5, which is the type that we need. How about this case? Alright, so because double has been already average has been already declared as double in the first line, I don't need to redeclare average. Okay, if I do, then the compiler might raise a compiler error saying that it's a redeclaration. So average already defined. Now we are trying a different kind of assignment where average is being given the value 100.0 divided by 8. Now here we may have some problem because our numerator is double but the denominator is an integer, right? So now whatever we have learned in the previous slide will be very handy in sorting it out. So what's the rule? First rule says that they should be in the same of the same type. Unfortunately we don't have it. So the rule says that in case we don't have the operands of the same numerical type, then the lower type is promoted to the higher type. So the lower type is the integer here. So Java will promote it and will make it 100.0. It was already 100.0 and 8.0, which means 8 has been changed to double. Now numerator double, denominator double, something like this. So the result should be no surprise. It will be 12.5. Okay, yeah, so here you have the explanation. 100 and 8 are different types. 8 is upcast to 8.0 and we proceed as before. Now this last part is very interesting because your numerator is integer, your denominator is integer. So for the right hand side we don't need anything. We can perform division operation without upgrading any data type. You have integer numerator, you have integer denominator, you can perform the division, but that division would be integer division, so the result would be 12. 12 would be the result of this division, right? But once you assign 12 to average, which is double type, then this 12 will be represented as 12.0. That's it. Okay, so this is interesting, and please try to understand what I'm explaining through these examples. Okay, so you do have the explanation here that 100 and 8 are both integers, so we perform integer division to get 12, and this is upcast to 12.0. Only when you are doing this is upcasted to 12.0 during assignment. Okay, yeah, all right. So these values are, this case is different from the previous two. Let's have a look at one more example. Okay, these concepts are important, so we have examples. So what's going on here? Well, the same kind of thing we have on the right hand side, the same value. double in the numerator, double in the denominator. So if you are only paying attention to the right hand side, then this will result in 12.5, which is a double. Now look at this, the variable. It is sum grades, right? That's the name, sum grades. But what is its type? Its type is integer. And to an integer type, you are assigning a double value. Will it work? Please think about it. It should not work. Why? Because you are letting Java do this conversion of a higher type of value of the double type to an integer type, which will not happen by default. Okay, so this is a compiler error. So the same is explained right here. This is double, both are double. Their quotient, their result would be 12.5, is also a double. But double to integer is a problem without cast, right? You don't have a cast. If you do a casting, then you'll be fine. So the cast must be explicit. You are banking on implicit casting, which will not happen here. Okay, in this case it will not happen. It happens from lower data type to the higher type, but not from higher to lower. Okay, fine, we got it. How about this, right? We are doing some casting here. Let's see how effective this casting is in this way. So I will solve the right hand side. Okay, so let me see like what does this mean, the right hand side. When you say int 100.0, then it will result in the 100.0 being converted to 100 as an integer, and then this is being divided by 8.0. This casting that you have is confined to the numerator only. This casting is not applied to the denominator, okay, only to the numerator. So the effect of that was 100 divided by 8.0. So now can we do this division? No, not in this form. What should happen? We should make these two the same type. So in that effort, just to compute the division, 100 will be upcasted again to 100.0 divided by 8.0, which is similar to what you had in the previous case. And this whole exercise, even after the inclusion of int for casting, would result in 12.5 only, and we are back to square one. The same situation that you had in the first case, 12.5, which is a double. You want to assign that to an integer variable. A problem here. Okay, so compiler error you get here as well. Alright, good. So now let's see what do we have in the last case. How is that different? We are doing casting here as well. But how will this casting work in comparison to the casting that you had in the previous case? So since you have the parentheses, right? So whenever you have parentheses, then in the mathematical expressions or the arithmetic expressions, what we do, we first compute the expression which is inside the parentheses. So we will do the casting later. Let's first compute the expression that you have in the parentheses. No problem here. Double in the numerator, double in the denominator will give us 12.5. Okay, the double result. But now you are doing casting on 12.5, which should result in 12, which is an integer. It will truncate. Now this integer value can be easily assigned to an integer variable with no complications at all. Okay, so now you are fine. You will not get any compiler error, and the sum grades will have the value as 12. No rounding, it's truncation. Alright, good. Now this last example on the same concept. So if you declare 50%, which is your double variable, and you want to initialize that to this expression, which is 50 by 100. Now what value is 50% getting in this case? So let's solve the right hand side first. Okay, this is my suggestion. Always solve the right hand side first, and then think about the assignment later. So 50 is integer, 100 is an integer, right? So both the operands that you have in this division are integers. So the result will be an integer, which is 0. So the division of 50 by 100 would be 0 because numerator integer, denominator integer, you are doing an integer division. So the quotient is 0. Now this 0 will be assigned to 50% and 50% is double. So ultimately 50% will get 0.0, not 0.5. Okay, that will not happen because it's integer division. How about the second case? In the second case, you have double in the numerator, double in the denominator, so the result would be 0.5. Okay, and 0.5 is assigned to 50%. That's what you wanted probably. Okay, yeah, so we have this explanation which you can go over. Alright, so now to a very interesting part, which is conditionals and decision statement. So often when you are writing a program, you need to make a decision. Alright, so your programs will be more complicated than what we have seen. So in the program, you will have to decide like what to do. Okay, so if you're thinking about general scenarios, so it may so happen that you're writing a program which has a menu in there and you're asking the user to provide some input. Say you have written a calculator and you're asking the user to maybe input A for addition, right? And then you may say that please input B for subtraction. You can go on. Right, so that will be a menu-driven program where you are prompting the user to input a character, and on the basis of that character input, you will perform some operations. All right, so in these cases, you need to make a decision. If the user is saying it's an A, then you have to perform addition. If it is B, you need to do something else. So these are conditionals, where you need to decide like what to do from the different options available. Now Java has some statements which will help us in dealing with these scenarios. We can have these decision making capabilities by using some statements, and these statements they fall in the two categories: branching. And the branching we have if else statement, and there's another concept in Java which is selection. So you can do selection as well, and for selection we use switch statement. So we'll learn about these two statements today: if statement, if else statement, and switch statement. So in fact we have three statements. The branching can be done in either using just if statement, or you can use if and else together. Alright, so there are two options available for branching. This is one-way branching, whereas the if else is two-way branching. And then we have selection using switch statements. Alright, so let's let's learn about this boolean thing actually, because boolean is very important in conditionals. So what I should be doing, I want to do a demo, and this demo would involve an IDE, and I like Eclipse, so I will give you the demo using Eclipse. So let me open Eclipse here. I hope you install the IDE. I'm not sure whether you are using Eclipse or something else. Since it is being already installed, so I'm not showing you how to install it, but I think I shared some document with you about installation. If not, let me know, I can share that. So once you open the Eclipse, then it will look like this. First time it will have some welcome message as well, but since I'm not using it for the first time, so you won't see the welcome for me. So what do? You go to file if you are doing it for the first time, and in the file you'll say new, and you should pick a Java project. So let me pick a Java project which is summer CSE114. Okay, point 2. I will say next, and then I should say well, I don't want this guy to create a module info.java, because that creates some issues which were not there in the previous version of Eclipse. So I'll say finish. Alright, so you might face this problem because I faced. So I will not let it create a module. Now when you go here, you'll find source folder. I will click the source folder, and with the right, I'll use the right click of the mouse on source. Then I'll say new, and I'll ask this guy to create a new class. Okay, so let me give some name to my class. I will, what should I say? I should call this demo. Alright, so demo.java. Okay, so now it will open this kind of template for me. So it already created a class, public class demo. I don't need to do anything for that. Now I will start writing my main program, public static void main. Okay, so here in the main I need to follow the same arcs, right? Okay, good. So let me write a very simple program, hello world, because my purpose, first of all, my purpose would be to show you how can we write a program in an IDE and get that to running. So this is the simple hello world program. So you need to write that, and I hope you followed the step. How did I create a project? First you need to create a Java project, and then in that Java project you'll go and find the source src library, and that src library you create a Java class. Okay, yeah, fine. Now we can run, right? So I will run this program, and you can see the output right here. So this is a lot simpler than the way I was doing in my previous video lecture. If you remember, I was using command prompt, and before command prompt I wrote my program in in um, in an editor, Sublime editor I used, and after writing the program on Sublime editor I would compile it by using Java-C, and then after the successful compilation I use Java. I invoke the JVM to run the class file. So that was little more involved, typing everything in on an editor, then compiling, and after compiling running that. If you have an IDE, it's very simple. You have to do everything right here, write your program here, and then when you run you can see the output in the console, right? So this is the console. Fine. Now since I am about to we are already looking at conditionals, so let me give you some idea about the true and false, the Boolean thing. So Boolean is something we need to discuss. So let me write this system.out.println statement, which will print whatever you have in the parenthesis, and here I will do something interesting. I'll say 3 is greater than 10. Alright, so now if I ask you what is the output that you're expecting, I'm saying 3 is greater than 10. Do you agree? Probably not. Right, so let's see what will be the output. False. Right, this is not the case. 3 is not less than 10, so it will say false. Right, so Boolean is something which we get as an output when we use comparison operations. Right, so if I make this 30 greater than 10, is that the case? The output should be true. Alright, so when you are doing this comparison operation, then the comparison operation will result in the value which will be either true or false. So now let's make it more concrete. I will say Boolean result. Alright, and then in that result that I have, the result can store something like this. Alright, and here I can write my program in this way. I'll say the result of the comparison is plus result. Alright, so if you run this program, you'll get the output as true. The result is true. That means this this comparison will result in true. 30 is greater than 10. Okay, so what's the type of this result which you are getting after this comparison? It is Boolean. Boolean means, let me write that comment here. Uh, Result can take only two possible values. What are these? True or false, not both. Okay, so that's the Boolean thing. Back to the lecture slides. All right. So true and false values. A Boolean expression is one whose value would be either true or false. We just saw that. So if you have two variables a and b, and there is some value in a and b, then you can check whether a is greater than b or not. So if a was, let me use pen because that will help. Now it depends on what you have in a and what you have in b. So if a is 10 and b is 2, then this is true. Okay, then this should result in true. And if a is 10 and b is 20, then it should result in false. Okay, so it will be true or false, but cannot be both. So this is the comparison thing. Now the most important thing is right here. Alright, which is two equal operators that we had in mathematics, right? So these two equal operators that we had in mathematics for testing the equality is used in Java for checking the equality. Alright, so in Java, right, let's discuss in Java. In Java programming language, the operator, this is assignment. Right, so the equal operator that we have in mathematics, if you just use that once, then it is an assignment operator in Java. But if you use two of those next to each other, then that will be used as a test for equality. If you want to check whether a is equal to b or not, then you should put two of these operators, not one. And this is a very common error, very common programming error for when we it's a very common programming error by most of the programmers. But when you start programming, when you're new to programming, then you should be very, very careful about it. Okay, so whenever you have to check for equality of two variables, please use this operator, not this one. Okay, this is assignment, this is not equality. Okay, let's move on. So Boolean operations. So whenever we have to make some decisions, then these decisions involve some comparison. Okay, and those comparisons or those expressions which we use in making decisions, they tend to become Boolean operations. That means if you perform those operations, then the result of that will be either true or false. And in these operations we use these relational operators, right? So what are these relational operators? Greater than, less than, greater than or equal to, less than or equal to, equality, and not equal to. Alright, so these are the relational operators, and these are binary. You will have a and b, and on the basis of this computation you'll get either, on the basis of these comparisons you'll get the results as true or false. Alright, so then we have the logical operators as well. So logical operators are used to combine more than one Boolean expression. Okay, so often I'll use a demo to give you some idea about logical operators, and very often you will have a situation, or you will be writing a program that involves more than one decision, right? So if that is the case, then we will use these logical operators to combine multiple Boolean expressions. So it will make more sense when I take an example. So it's a high time that I should do an example. Okay, let me see what do I have in the next slide. Alright, so well, you have these relational operators that I had in the previous slide. It is more systematic. because every operator has its meaning and an example. This is a less than operator, so you can use age is less than 30. That's an example. Greater than, height is greater than 6.2. Less than or equal to, which is taxable, is less than or equal to 20,000. Greater than or equal to, similarly, if the temperature is greater than or equal to 98.6. For equal to, you need to use this operator. And then not equal to, you'll be using exclamation mark followed by the assignment symbol. Number not equal to 250. Grade is equal to 100. Okay, all right. So now the logical operators, right? So let me give you some idea about these logical operators, then I will use these operators in a demo. Okay, so all right, yeah, that's fine, that's fine. So assuming that I need to you know let's take some example. Integer a equals 10, integer b equals 20, integer c equals 15. Okay, so now it depends, right, like what kind of problem you are trying to solve. So if I say that find out the number which is greatest, right, so the number which is greatest, how will you find that out? Well, you can say that, right, well, this will be a little interesting actually. Well, let's think about two Boolean algebra, right? Let's not worry about what we have to do. Let's think about some Boolean expressions. So Boolean condition, this is CON, wait a second. I should say Boolean condition 1 is equal to b greater than a. Alright, and then you will have Boolean condition 2 is equal to b is greater than c. Alright, so now using condition 1 you will tell whether b is greater than a or not. That's one condition that you're checking. Similarly, in the second condition, which I am calling as condition 2 cont 2, its type is Boolean as well. I'm checking whether b is greater than c or not. Alright, so since I'm making use of this comparison operators, greater than, my answer to that would be either true or false. So for that reason, since I'm expecting true or false as the outcome of these comparisons, I need to store that in Boolean variable. So I have condition 1 as well as condition 2 declared as Boolean. Now if somebody is saying that, tell us whether b is the highest or not, do I have the maximum value in b or not, right? So when will I say that b has the maximum value? Only when condition 1 is true and condition 2 is true. Both the conditions are true. Okay, so we have these logical operators like AND operator, OR operator, NOT operator. So these operators are very handy in dealing with these kind of situations. Right, so let's look at AND operator. How does AND work? Now this AND will be true only when both the operands are true, which means Boolean result. So if you are having Boolean result, this doesn't look good, so let me use result. Okay, result is equal to condition 1 This is my 1, and I should have and condition 2. Let's put that in the parenthesis, although that is not needed, but I have this habit. You don't lose anything by putting the parenthesis. Now this result would be true only when the condition 1 is true and also condition 2 is true. Alright, so luckily in our case, if I let you look at this and evaluate, you will find out that our result is going to be true. Why true? Because both of these conditions should be true. You know, this result of the AND operation, which is in fact combining two Boolean operands, right? Condition 1 is a Boolean, condition 2 is a Boolean. The value that you get for condition 1 and condition 2 depends on the expression number 1, on the statement 1 and statement 2. In our case, these are true because B is greater than A and B is greater than C. So these two are true. Because these two things are true, then only we will get the result as true. Alright, and if I somehow change this condition, let me change this condition. In place of B is greater than C, if I change that to B is less than C, okay, so condition 1 will remain true, B is greater than 10, but in this case B is less than C, B is 20, C is 15, B is not less than C. So condition 2 will become false. And when one is true, the other one is false, then the result is false. Alright, so for an AND operation, both the operands should be true. Whereas if you have OR, right, so OR is slightly different. The OR logical operand will result in true if one of those are true. Okay, so let me change this logical operator to an OR operator. And I should erase this as well. Because now we will look at the OR operator. An OR operator means these two pipes. The vertical lines that you have are called pipes. So condition 1 is true, condition 2 is false. It doesn't matter, we just need one of these two operands to be true. At least one of these operands should be true. If both are true, anyway that is true. And if any one of these two are true, you'll get a true. Okay, so the result gets a. So there are some very interesting cases where your output depends, where your program will give you some insight, like whether you have to use the logical AND operator or you have to use the logical OR operator. Now this logical NOT is totally the opposite. So if you know I can write that here, so let me write one more Boolean variable, Boolean result 2 is equal to NOT of result. So what will happen in this case? If the result is true, then you're negating it, right? So here we had the result as true. Then once you put an exclamation mark before that, then it will just reverse that result. So true will become false. So here, when your result was true, result 2 will get a false because we are using the NOT logical operator. Okay, good. So before I take you to if, or maybe we should look at an if. After if statement and if else statement, then I'll write a demo which will involve all these things. It will involve the logical operators, and it may involve relational operators. Yeah, it will involve relational operators, so don't worry about that. Okay, so what is the purpose of a statement? How do we write an if statement? Now this if statement uh, is written in this way, right? So this is the general expression. You write if, and then if is followed by parenthesis, right? So if followed by parenthesis, and inside the parenthesis you have a Boolean expression, and then you have the body of the if statement. Now this body of the if statement only is executed when the Boolean expression that you have it results in true. If this condition is false, so this condition is expressed in the Boolean expression. Boolean expression means when you solve this expression, you'll get either true or false. So only when this expression results in true, your body of the if statement means all the statements that you have in this block, or starting curly braces and ending curly braces. Only when the Boolean expression is resulting in true, you will execute the statements in the if block. Okay, so here we have a flow chart, right? I hope you have some idea about flow charts. If not, then please have a look at that. So flowcharts are very common and very important tools in understanding the flow of a program, the logic of a program. Okay, so if we use this flowchart, I'll give you some idea about flowcharts. So here we have some structures here. So you're looking at a diamond. So in the diamond, usually we have decisions. We make decisions in diamonds. And then we take some action in the rectangle. So the same this if statement that you have written is being mapped to the corresponding flow chart, which says that you will follow this sequence and you will check the condition, and this flow chart is explaining the execution of the if statement. Alright, and how does this if statement works? You will look at the expression, a Boolean expression, which will determine your decision. Your decision is based on the computation of the Boolean expression, and if that results in false, then you skip these statements. What statements? The statements which are in the body of the if statement. In case the Boolean expression results in false, just skip the body of the if statement. Otherwise, if the result of the expression is true, you need to execute the body of the if block. Alright, so let's take an example to understand that in a better way. So let's use this case where somebody will give us the radius of a circle, and if the radius is positive, then only we will compute the area. Otherwise, negative radius makes no sense. So what we will do, we will put a Boolean expression here, right? Is this Boolean? Yes, it is Boolean expression. Why is this Boolean expression? Because you give me a radius value, I can apply this expression and the result would be true or false. So if radius is equal to 10, then well, 10 is greater than or equal to 0, which means my condition is correct. I'll go on and I will execute the body. Radius being greater than 10 or equal to 0 will result in a true. And if this expression in the parenthesis is resulting in a true, we will execute the body. If not, we will skip that. We will not compute the area of this circle. Excuse me. Okay. Fine, so now that was okay. If I change the radius to minus 10, what will happen? So if your radius is minus 10, then you will fail the test here. When you'll say if radius is greater than or is equal to 0, this will fail because your radius is minus 10, and this should result in a false. So because the expression is resulting in false, so you will skip that body, right, and you will come out. So the same thing is reflected in this example of the flowchart as well. Look at the radius and then decide. Excuse me. Alright, so the same thing, right? We will have more examples about if statement. If in the parenthesis you'll have the condition, which will be a Boolean expression, and on the basis of that you will execute the body. So another example, if the length is less than 2, then you might like to print out that it is too short. Similarly, if age is less than 16, you will say too young to drive. Another example, if password dot equals foo, then you will have access granted, right? So it seems like this is a portion of a program which will determine whether you have the access or not. But pay attention to the way we are using if statement. That's the important part. In the parenthesis, whatever you have in the parenthesis of if, whatever you have is a Boolean expression. Now there are certain rules about if statement. Well, you might find this thing, the heading saying as one way, because we are just using if statement. When you use if along with the else statement, then it is called a two-way statement. Alright, if you just use if, then that is one-way statement. Because let me tell you why is it one way. You are just saying that if this is true, do this, otherwise you go out. So in the two-way if statement, you will have if true go this way, if false go this way. Alright, so with if and else you'll see the two-way if statement. Since we are just using if, so it is called one-way if statement. So what are the rules? Now the condition containment is necessary. That means you cannot use if this way, right? The condition that you have, or the Boolean expression that you have, it should go in the parentheses, right? This is the best way. The condition that you have, condition containment is necessary, which means the Boolean expression that you have, it should be in a parenthesis, and that parenthesis comes after the if statement. If, then the parenthesis. The other thing is that block containment is not necessary. What does that mean? Well, if you have written if statement in this way, which says if I is greater than 0, then print this statement, this is perfectly fine. Why? Because by default this if applies to the very next statement that you have. Okay, so the way you have done written it, then it is equivalent to having something like this. So whether you put one single statement after the if in the curly braces or not, it's the same thing. So the block containment is not necessary, but condition containment is necessary. Containment means putting that in either parentheses or in the curly braces. So condition containment is must. You must put the condition in parentheses, but the block containment is not necessary, because by default the if condition that you have, or the if statement that you have, is applicable to one statement after the if. Okay, so yeah, whether you put the curly braces starting or ending or not, it's the same thing. Pay attention to these points, please. Now we are coming to if and else statement, which is two-way if statement. Why is it called two-way? Because there are two possibilities, right? So if it is true, then we'll do one thing. If it is false, we'll do the other thing. So in the previous case, if you remember, if the radius was less than, if the radius was greater than or equal to 0, excuse me, we computed the area, and if not, we just skipped that. We did not make any statement that the radius is negative. So if you do something about the radius being negative, then it will become a two-way statement. We just skipped that, right? Yeah. So with if and else, with if and else statement, it is possible to perform two execution paths. So this should make sense now. Use if, and in that if statement, you will have a parenthesis, and in the parenthesis you'll have the Boolean expression. And now when this expression results in true, we will do some sets of experiments which are in block 1. If that is false, then we have different sets of statements which we'll perform in block 2. Okay, so look at this flow chart. It should make a lot of sense. So this flow chart is giving the controlled flow of a program in which you're using if-else statement. So now you're coming in this way from the top. You have a Boolean expression which is in the if thing, right? So the same Boolean expression that you have right here is in the diamond. So on that basis you will decide like what's the value we are getting. Are we getting true or false? So if it is true, then we have some sets of statements to perform for true case. If it is false, then we have another set of statements that we want to execute for the result being false. Okay, so there are two ways. One way when it is true, the second way when it is false. Alright. So yeah, you can see, right? In the previous case, we did not say anything when the radius was negative. But now we are using as, and we are saying that the radius was negative. Okay, good. Now there's another thing actually which relates to the common mistakes that we often make, where after this if statement we put a parenthesis, we put a semicolon. Alright, so when you put a semicolon after this if statement, then what will happen, this if will not have anything in its body, right? If you do it this way, then the body of if, or the if block, body of if, or the if block that you say if is empty, right? So this condition that you have is not applicable to anything. So probably you wanted the statement right here, which is system.out.println, which is in fact correct, because you want to print that x is greater than 5 only when x happens to be greater than 5, right? So you want this statement to be printed when the condition is true. But when you put a semicolon here, then what will happen, the whole if condition would be killed right here. Killed means it will not have any impact on the second statement that you have, and this statement that you have will always run irrespective of the value of x. Whether x is greater than 5 or not, you will get this output, right? So this is a bug in your program, so be mindful of that. It's not a compiler error, but it is a bug. Compiler will not complain about it, but your program will give unpredicted result. Okay, so we have the same thing which you can read. Now well, this is about the fact that whether you have the curly braces after if statement or not is the same thing. You should have the curly braces after the if statement when you want that if statement to be applicable for more than one statement. Alright, so let me read it, right? So probably reading that will make more sense. An if statement executes its body when the condition is true. Okay, we understand that. If the condition is false, the body is skipped and the execution picks up at the first statement after the if. We know that. Now by default, this is important, right? By default, the body of an if statement is restricted to the first statement that follows the if condition line, right? And indentation does not work. So if you're coming from Python background, then be careful. In Python, the indentation works, but in Java, the indentation is mostly for the styling compiler doesn't consider indentation at all. So if you want to enforce some order, then you will have to use blocks with the opening and closing curly braces. So please keep that in mind. Now there's this concept of compound statements, right? So compound statement will make this thing even, it will make you understand that when should you use the code block, which means when should you use uh, the pair of curly braces after if statement. So let's look at this example and it will explain. Now what is this code block doing? Let's try to understand that. So it is computing salary for an employee, and in the salary computation we need to find out like how many hours the employee has worked as normal employee, and for how many hours this employee is claiming the overtime. So if the employee is working for 40 hours, then for those hours the employee will get the regular $8 per hour. And if the employee is putting more than 40 hours, then for extra hours we'll be paying the extra money, overtime pay. So how do we compute that? Okay, so this complicated computation we need to do only when the employee has worked for more than 40 hours. Okay, so please check that this hard work, this whole computation, we want to do only for the employee who's working more than 40 hours. If it is less than 40 hours, then we'll do hours multiplied by 8 and we are done. So if the employee is working for more than 40 hours, then what we do, we find out the hours which are extra. And how do you find extra hours? That will be hours is equal to hours minus 40. Okay, and then for these extra hours that this guy has worked, we will compute the extra pay or the overtime pay. And overtime pay means these additional hours that the employee has put in. Let me put, let's put some value. If the hours were 53, right? So these extra hours that you have right here would come would be 13. 13 plus 40 is 53. So here you will find out the overtime, so which will be 13 multiplied by 12.0. Okay, so the overall pay, the total pay that this person should be getting would be the normal pay that he will get for 40 hours, which is excuse me, 40 multiplied by 8.0 plus the overtime pay. Alright, now why is this example important? Because these statements that you have, which is statement number 1, statement number 2 and statement number 3, in that sequence, all these statements need to be applied only when this condition is true. So we want this if to be applicable to all these 3 statements, not just one. So when you want the if condition to be applicable to more than one statement, then we should put those statements in the opening and closing curly braces. Okay, and this statement that you have, which comprises of these 3 statements, is called a compound statement. Alright, so whenever you have a compound statement, you should make use of opening and closing curly braces. But it is always better to be safe, so you can always keep opening and curly braces even if you have just one statement. There's no harm in doing that. Okay, so you can have nested if statements as well. So, let me give you an example to explain that. Alright, so this is good, right? So nested if statements means that in one if statement, if you further want to check whether another condition is true or not. As an example, if the income is greater than 25,000, all right, if that results in true, then you want to check again. What? You'll check if the deductions are less than 3,500 or not. So this is possible. Inside an if, you could write another if and else statement. Okay, I should do some demo for nested if and else statements also. So you can have if else chain as well. Like this, you are checking for expression 1. If this expression 1 is true, we will do the statement 1. If that is false, then you'll do the else part. If this is true, great. Else, we will do something which results in, which is opposite of the expression 1. And here again you have a nested if. If expression 1 is true, we'll do statement 1. Otherwise, we'll check the second expression. This is different than this one, right? And on the basis of the result of expression 2, now you will decide if that was true, do the statement 2, otherwise do the statement number 3. All right. So let's look at this example. This example is an interesting section of a program where we want to convert the numerical grade of students to the letter grade. So the rule is such that if the student has received a numerical grade of 90 or above, we'll give the student a grade of A. Otherwise, if it is not greater than or equal to 90, then we'll have to think about other grades. So how do we write this program? If the grade is less than 90, now we will check, right? So this section that you have right here, this section will only the program will only come to this section when the score is less than 90. If the score is equal to or greater than 90, anyway the student is getting an A. So for this case, when the score is less than 90, we have a number of cases that we need to consider. The score might be C, might be D, or might be F. So how do we systematically do it? We should have another nested if in the else block. So what is the nested if doing? Well, when we know that the score is less than 90, let's check if it is greater than 80 or not. So if the score is less than 90 but it is greater than or equal to 80, then we'll give the student a grade B. Otherwise, if it is even less than 80, now we should check, is it greater than 70? If yes, give a C grade. If not, again check whether it is greater than 60 or not. If that's the case, give a D, otherwise the student is getting an F grade. Okay, so these nested if and else are very, very important. So you need to first of all think about it. You have to think the logic first. And when the logic is clear, then you should think of mapping that to the Java syntax. So here we have written if else statement. If you want, you can make it more compact by putting if just next to the else. So the only difference that you can find in the code on the left hand side and the code on the right hand side is that here the else if thing is being put in one line, which will make your code very compact. Otherwise it's the same thing. We have nested if and else statement. Okay, else if or else. Alright, so what I will do for today, I will stop my lecture slides right here, but I want to do some demo for you. So the demo should start with if statement, okay, if and the logical operators. Let's work on that. I will keep these things and let me go back to the excuse me, to the Eclipse. So now let's use the scanner class. Import java.util.scanner. Alright, why am I using scanner? Because I want to get the input from the user. Scanner std in is equal to new. Please practice these things, okay? Scanner system dot n. Alright, I explained to you why we use it, right? And I will use this statement later. So you know what, if you look at this yellow thing, then this guy is complaining about the fact that you are not closing stdin. So what we should do, we should say stdin dot close. Alright, after that the compiler would be happy, and usually I close stdin towards the end of my program. Alright, close, good. So now what I should do, let me prompt the user to please enter an integer. Alright, so int x, and x is equal to stdin dot next int. I hope you have done all these things, right? So this is based on my previous lecture. So here I gave you some idea about the scanner class. We will use the scanner class so that we can get the input from the user. So that's the reason I'm doing that. Imported the scanner class, and then I want some input from the user, and here the user, I'll be the user. And when I will put some input which will be an integer here, then that should be stored in an integer variable, and x is that variable. So let me check that I'm able to correctly read the input. It's always better to check your program at every stage. So you entered the integer, sorry about that, x. Alright, so when we run this program, let me try 100. Okay, so yeah, I'm successful in reading these values, minus 25. Good. Right, so that input is working fine. Now let me tell you what I want to do. Since we have learned about the Boolean thing, and we learned about some operators, we learned about logical operators and all. So let's start writing some program which will involve the usage of those operators. Excuse me. So let's write this program which will check whether the input that the user is providing is an even or odd, right? So how will you check whether the input like x is even or odd, right? So please think about it. So the test that we need to do, check if x is even or odd. So how do we check whether x is an even or odd? We need to check the divisibility check whether x is divisible by 2 or not. Alright, divisible. Alright, good. So now for that, let's see how do we check whether x is divisible by 2 or not. So we should have this mathematical understanding that how do you check, right? So divisibility is something we will need to check using we should use modulus operator, because it will return the remainder Okay, and if the remainder is 0, that means it is divisible by 2. So how do we do that? Let's use an if statement. If we'll write an we will write an expression which has to be a Boolean expression. So if x remainder 2, what will this do? If you're saying x remainder 2, that means you will find out the remainder. Okay, if that is equal to 0, what does it mean? It means that when x is being divided by 2, what is the remainder that we are getting? If the remainder is 0, that means it is an even, right? So what you will say, is an even integer. Alright. Otherwise, if that is not the case, then what should you print? You will say let's make that capital even. Odd integer. Alright, so what are we doing here? We are making use of if and else statement. Look at the body of this logical expression here. You are dividing x, which is the input that you get from user, by 2, and you are paying attention to the remainder. So if the remainder is 0, then that means it is an even integer. If the remainder is non-zero, then it means an odd integer. Alright, so let's run this program. 25. Okay, so we know that 25 is an odd integer, right? So we got that correct. Let's try some even integer. Okay, it's an even integer, right? So this is working. Let's try one more. 31. So please try this program, right? Yeah, if you have never written any program like that, it might take you a little longer, but don't worry, don't give up, because we are just starting, right? And it will be fun. If you do this exercise, it will be fun and you would love programming. Practice is what you need. Reading, if you're not following my lectures well, then please read the textbook and bother us in our office hours. I have 3 TAs right now in this semester. Okay, so yeah, don't hesitate. Please check with us. Okay, good. So I showed you a very simple, program which is using if and else to check whether the input that you have is even or not. Now, let's make it a little more complicated. We have done this case of even and odd. So what I can do is that let's make it more complicated, and let's check whether the number, if it is even, then is it divisible by 5 or not, right? So we have two conditions now. So okay, let me delete everything. I have to, okay, let me create some Boolean is even and divisible 5 divisible. Alright, so what I am doing, I am writing, I have created two Boolean variables, is even and 5 divisible. So what I should do, I need to check whether this input that we are getting from user is even or not. So how do I check is even? Is even is equal to x, the same test that I had. X remainder 2 is equal to 0. Alright, so now when this is divisible by 2, then the modulo would result in 0. Same logic you can do. You can perform with, excuse me, 5 also. Now the question is, how will you check whether x is divisible by 5 or not? Well, just use this logic. In place of 2, we will use 5. Alright, so now we will check whether x is divisible by 5 or not. So the same thing which you're using, the same concept that you're using to check whether it is even or not, we can try that with 5. And if the remainder is 0 after your division by 5, then it means it is divisible by 5. Okay, so now we can make use of these two Boolean expressions and also the logical operators. Okay, so let me tell you what I'm trying to do. If I say that if is even and, right, if is even is true and also 5 divisible is true, let me copy this thing. Then what should I say? System out x is even and divisible by 5. Alright, so this will only happen when both these conditions are true. Alright, so let me run this program. I can make it more complicated, but let's start with a simple case. 2. Alright, so this statement is not printing out, because for this statement to be printed out, we need both these conditions. What is the condition? It should be even, and at the same time it should be divisible by 5 as well. So 2 is even, but it is not divisible by 5, so we are not able to enter this if condition. Let's run that again, and now I will say 10. So this 10 is one which is even and as well as it is divisible by 5. So this condition that you have here, right, it will be true, the whole of this if condition will be true when is even is true as well as 5 divisible is true. Alright, so if you want, I can change this and to the or. Alright, so when I change that, then you can see that even for the input like 2, I am getting this output as is 2 is even or divisible by 5. So this is correct, 2 is even, but it is not divisible by 5, right? So that's the difference between or. One more time, let's put 10. So interestingly, 10 is both, it is even and it is divisible by 5 also. Let's try 15. So 15 is not even, but it is divisible by 5, so we will get this statement. 15 is even or divisible by 5, right? So it is not even, but it is divisible by 5. Alright, so I think I should stop right here. There are a lot of interesting demo problems in my mind, so maybe I'll try that in my next video lecture. Please let me know if you have any questions on what I taught today, and yeah, join me in my office hours, or else send me an email or join the office hours of my TAs. Thank you so much, and I'll see you in the next video lecture. Bye bye.